Today I'm going to show you 3 different strategies to convert improper fractions to mixed number fractions. So here's our first example. We have 14/5. That is an improper fraction because it is greater than 1 whole. Our top number is bigger than the bottom. So the first strategy is to draw models. I know that my denominator tells me how many pieces are in 1 whole. So I would need to draw a bar that has 5 pieces in it to represent 1 whole. Now I'm going to shade these in until I have shaded in 14 of them because that's what my numerator tells me. So let's go. 1, 2, 3, 4, 5. I've colored in 1 whole, but I need color all the way up to 14. So I'm going to make another whole. And I've already counted up to 5, so then I'll keep going. 6, 7, 8, 9, 10. Once again, I still haven't reached 14, so I'm going to make another whole. 11, 12, 13, 14. Now I have made 14/5. And from here, it is easy to see that I have 2 whole bars that are filled in with 4 of the 5th pieces left over. Now here's another strategy that I think takes a little bit less time than drawing out models. Instead, we're going to take 14, we're going to make groups of 5 and see how many groups of 5 we can make. So I'm just going to do this with tally marks. 1, 2, 3, 4, 5. Well, there's one group of 5, so I'm going to make that into a box, meaning that that is 1 whole. Then I'll keep counting. 6, 7, 8, 9, 10. There's another group of 5. 11, 12, 13, 14. So there are my 14/5. My fifths are just represented with tally marks. From here, I can easily see that I have 2 wholes or 2 groups of 5 with 4/5 left over. Now there's one more way that we could do this. Remember that fractions are really just division. So we could think of 14/5 as 14 divided by 5. When I do that, I know using my 5 times tables, the closest I could get is 10. That is 5 times 2, but I would still have 4 left over from my 10 to get all the way up to the number 14, giving me 2 with a remainder of 5. Now all of these models are telling me that I have 2 wholes and 4/5 left over. So 14/5 is equal to 2 and 4/5. Let me show you another example. If I had 41/9, if I was doing the very first strategy of drawing out models of using fraction bars, I would need to divide it into 9ths. Then I'm going to count all the way up to 41. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 1 whole. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. Whew! From this, I can tell that I have 4 whole bars filled in with 5/9 left over. Now, I don't know about you, but I don't really want to take the time to draw all those boxes and color them in. I feel like that would take me too long. So a little bit of a faster strategy would be to do the tally marks. So we're going to do the same thing, but instead of drawing out whole boxes and coloring them in, we're just going to make groups of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a box around that. 10, 11, 12, 13, 14, 15, 16, 17, 18. Put another box around that. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. Doing it this way, I feel like I am less likely to make silly mistakes, as long as I have my tallies that are separated out enough to be able to see them. Then I can tell that I have 4 wholes or 4 groups with 5/9 left over. Now an even shorter and simpler way is to just divide and use your multiplication facts that you already know. I can think of 41/9 as 41 divided by 9. If I use my 9 times tables, the closest I could get to 41 is 36. That would be going 9 times 4, but I would still have 5 left over in order to get it up to 41, because I would go 36, 37, 38, 39, 40, 41. That is my 5 that is left over. All of these models are showing me that 41/9 is equal to 4 and 5/9. They are worth the same amount.